it work? Yes, it works. Great. Awesome. Thank you for having me. Thank you for inviting me. Thank you for giving me the chance to talk about two things that are really near to my heart. On the one hand side, Go, and on the other, Azure. I would like to bring these two things together and showing you how you can use Azure Pipelines, the CI/CD solution in the Microsoft Azure Cloud, together with Go. I did not prepare any slides. The only slide I have is this one. It points to a GitHub repository where you can find the sample that I'm going to show you. We are going to build everything from scratch. So okay, headset doesn't work. I don't know why. Yeah. Oh, here.
Yep.
Does it work?
Yeah.
Okay. It was muted. So we will build everything from scratch. No, we will not write a lot of Go code today because the focus is on continuous integration and continuous delivery. But everything else, building the pipeline, running it, deploying everything to Azure with a multi-step pipeline and all this stuff, we will do that from scratch. I've prepared a bunch of code snippets, so you will not see me a lot of typing because I mistype on stage every time. So yeah, I prepared a bunch of snippets and you can find everything, including the snippets, on this URL here. Good, that's it. Let's get started. Let me quickly show you what kind of app I prepared. It's really a simple app. As you can see here, it's a very simple web API, let's put it this way. It's built with Gin, and what it does, you can use browser and go to /fib, and what you will get is you will get back a bunch of Fibonacci numbers. That's all this code is going to do. Please use your imagination. This can be your super complicated Go application, whatever it will do. Any kind of web application will do it. Inside of this application, I have a package here. I call it math algorithms, and you can find it here. And it's pretty simple. It just generates a bunch of Fibonacci numbers, an iterator where you can go through with the next function and you will get the current value with the value function. That's all. Why did I create this sub-package? Because I wanted to add some tests, of course. We would like to run some Go unit tests, and of course inside the CI pipeline we would like to run these tests, we would like to see the test results, we would like to visualize some code coverage information and all this stuff. So what we are going to do in the next 30 to 40 minutes, something like this, is we have to automate building this application in a serverless manner. So I don't want to run any kind of build agents or whatever. I'm going to use the hosted build agents provided by Azure in the Azure cloud. We want to build it, we want to test it, we want code coverage. At the end, we want to publish this stuff as so-called pipeline artifacts. So we want to have the build executable somewhere stored in the cloud. And as the third step, we would like to automatically deploy this stuff into a platform as a service or serverless web app, as it's called in Azure, where we run this thing. And whenever we change something, the whole pipeline has to run automatically and to publish everything on Azure. So this is the end-to-end scenario that we are going to build. Beside the application, which I will try now, just to make sure that I didn't mess anything up. Yep, looks good. And if we go on localhost 8080, let's see, we get some Fibonacci numbers. So it's running locally, everything is fine, we have done the debugging, we have done the coding, now we want to automate. Automation with Azure Pipelines works in a way, or modern way, is to write a so-called WAML file. You see this WAML file here, it's called Azure Pipelines, and in this Azure Pipelines file we will create, let's say, a recipe, a collection of steps and jobs that will be executed. And as we will see, we don't need to care for the build machines because they are provided by Microsoft, and luckily everything we need to build our Go application is already installed on this hosted build agents. We don't need to do anything by ourselves. So let's start with the first one. Trigger master is really continuous integration. Of course, we could do something much more complicated here. What this essentially says is whenever somebody checks something in on the master branch, please run this pipeline. The next one is a collection of stages. Stages means that you can take your pipeline and structure it into multiple parts. We will have 3 stages here. The first one is the building stage. The second one is a publish stage. We will take our application and put it into our Docker container. We're going to use an Alpine Linux and put our executable into it. We will publish this container on the Docker Hub. This is our second stage. And then we will have a third stage where we'll take everything and publish it on Azure. If we take a closer look here on this first stage, the build and test stage here, you will see that yes, it has some generic metadata, that's okay, and you have a bunch of variables. You can use these variables later on. You can make your pipeline easier to configure by using these variables, and these variables essentially become environment variables. And as you all probably, you're here at a Gophers meetup, are familiar with Go, you will recognize things like C Go enabled, Go OS, Go architecture, and so on. Maybe a little bit something that we should quickly talk about is the Go version here. I'm selecting the proper Go version for my application. I selected the newest one, the 1.13.5. But on the Azure build servers, the provided ones by Microsoft, they have installed, I think if I can remember it correctly from the top of my head, Go 1.11, 1.12 and 1.13, and you can ask to install at runtime while building your application essentially any version of Go that you would like to use and have installed on these machines. You will see in a second how this is done. Now inside the stages we can define so-called jobs, and in my case I just have one job per stage, but if it becomes more complex you can structure the stages in multiple jobs, and in these jobs the most important setting is this one. Every job has a VM image that is used for building this app. You can say parts of my apps are built on Ubuntu 18.804. You can say another thing has to run on a Windows-based build agent. Something runs on Microsoft provided build servers. Something else runs in my own company because I need to have access to some on-premise resources. Per job you have one VM image where you can define where your build should run. So in our case it's Ubuntu, and this version is provided by Microsoft. We don't need to care about it. By the way, Azure Pipeline is built in a way that you always get a fresh virtual machine whenever you build the pipeline. So all the times you start from scratch. Therefore, you cannot cache any kind of build artifacts from build to build. It's always on a clean slate. That's how the system is currently built. So next one. By the way, if you have any questions, please interrupt me. I'm happy to discuss it to make it interactive. Now the first step in our stage is this one. This is essentially the installer and version selector. What I do here, I'm using the variable and tell the pipeline, hey, I would like to have Go 1.13.5. If it is already installed on the machine, it's going to be selected. If it is not on the machine, it's going to be downloaded and installed in this freshly created VM. That's essentially this step. Please note this one here. This is the name of the task. Essentially, these tasks are ready-made bash scripts, mostly provided by Microsoft. So you do not need to write everything in a bash script, but you have dozens and dozens and dozens of build steps for nearly every major language that you can imagine. And the Go support is really good. And now a word of warning. If after this talk you get interested and would like to try it on yourself, please do me a favor and do not Google building Go applications on Azure Pipelines, because that will bring you to a documentation page which is horribly outdated. Don't believe this page. Azure Pipelines is much more capable than what it is said there. Unfortunately, the documentation is not very good. Let's put it this way. But I will tell you how you can do it. So go to my GitHub repository, you will find more accurate information there. I hope it will change in the next few weeks and months. The documentation team at Microsoft is aware of this problem and they are currently working on it, okay? But yeah, it is like it is. So this installs our tools. Next one. I would like to run the tests. Maybe let's do a blank line to structure our script a little bit. Now running the tests, as you can see, is a little bit more complicated. I will put it this way. I think on this big screen you can read everything really nicely. The problem with running the tests is not running the tests. That's easy. If you take a close look, you will find where it is here, something like this, go test. That's trivial. But the problem is that we need to bring the test results and the test coverage data in a format that Azure Pipelines can understand, so that we have a really nice UI where we see the test runs, the test results, the coverage data, and so on. Luckily, there are 3 open source projects available here which are capable of turning Go test results into JUnit files, and Azure Pipelines can understand JUnit result files. And following the same path, there are also 2 converters for converting coverage data into an XML format that, again, Azure Pipelines can understand. So what you essentially have to do is you have to write a little bit of script code that installs these 3 Go applications that are used to transfer the Go test results into results that Azure Pipelines can support. Everything else is just plain Go. What I do here at the end is maybe worth mentioning. I am checking the result of the Go test here. So I'm getting the result status, and if the result of the Go test is not 0, I'm writing something, as you can see it here, on standard error. If you write something to standard error, you can set a flag down here that says, if anything is written to standard error, consider this test to have been failed. So therefore the build will stop. This is what I have built here, okay? So that's an easy way of letting the build fail if your test fails, okay? After this script, we can be sure that our application was successfully tested, and we can continue. Next step. Now we can build. Luckily, build is really simple because there is a ready-made task from Microsoft. We don't need to write a bunch of bash script. All we need to say is go build, provide the necessary arguments. We want to compile everything statically because I want to run it on top of Alpine Linux without having to install any kind of dynamic linked stuff. So therefore, yeah, everything is fine. I call my executable, what a great name, demo. Okay, so keep that in mind. We are running our app, demo. Again, if you have any questions, please interrupt me. Next one, we need to publish the results. We do 3 published things here. This one publishes the demo app. Of course, we can make this more interesting and make the name of the application variable, but I think it's really simple. I publish so-called pipeline artifacts, and every build pipeline, every pipeline generally in Azure can deploy as many pipeline artifacts as it wants, and every artifact, which can be a folder or a zip file or an executable or whatever you want to publish, every pipeline artifact gets a name, and in my case I name this artifact executable. Yeah? And I can have multiple of these published things if I want to publish multiple executables, or if I want to publish, I don't know, the test results, or whatever you want to do. That's pretty simple. The next one is not publishing an artifact, but the next one is publishing the test results. Please recognize here the JUnit, the JUnit and XML extension here. I told you that I'm not directly consuming the Go test result files, the text files, but I'm transferring them into JUnit format with the Go open source tools that I mentioned before. They are not provided by Microsoft, they are just Go tools from the community. But here I'm just telling Azure Pipelines, hey, this is JUnit, take the XML and interpret it as being as it would come from JUnit. And yeah, I'm telling it it's in the sources folder, that's all. This one is worth mentioning always. Always says that this step in the pipeline has to be executed whenever I run my pipeline and independent of whether something failed before. So if my tests fail because I messed something up, I have a bug in my software, I still would like to publish the test results. Otherwise, I would have no idea which test really failed. Get the idea? This is the reason why I'm specifying the condition always here, to make sure that they're always exported. Otherwise, the build would stop at the failing test and I would never see the results. The last one is the code coverage. As you can see here, again, a ready-made step from Microsoft, and again, I used the recommended tool format that I generated with the custom tool that I showed you before. Everything else is just plain vanilla, telling it where to find the code coverage files. That's it. Azure Pipelines will take the test results and the code coverage files and give me a really nice UI later on when we run the builds. Okay? So we can take a look at it in a few minutes once we ran this stuff. Good. So now we have, let me quickly recap. We have installed Go, we ran our tests, we converted the test results, we published the build executable, and we published the test results, and we published the code coverage files. Sounds good to me. Let me quickly check what the next is. Yeah, the next one is already publishing and building the Docker image, but I think we can give it a try and just let this Azure Pipeline thing run to see whether I already messed something up. So let's check in our files. In this case, I would like to check in the Azure Pipelines file, add basic pipeline. Good. It's running on GitHub, so I'm just pushing it now to GitHub. Will only hopefully take a second if I still have internet. Yes, looks good. Now let's go here into my Azure DevOps. This is a completely empty project. I created it today in the afternoon when preparing this talk. Nothing is in there. It's really everything from scratch. We don't need to care about things like repositories because we use GitHub there. And the good news is if you are an open source developer, and as you might know, quite a while ago, Microsoft acquired GitHub and they have a big heart for open source developers. So if you have your code on GitHub and it's public, you will get the pipelines that I show you for free with unlimited build minutes. So you can really run your pipelines at a very low cost point, essentially zero. If you would like to use it for commercial things, of course, then you have to pay a little bit of money, but we have been using this stuff for quite a while and it's really cost efficient because I don't need to care about the infrastructure. That's the big point here. In my case, I'm going to focus on the pipelines area here. I'm going to pipeline and here creating the pipeline. I could, if I want, use the so-called classic editor and then I get a really nice click and point and drag and drop UI where I can build the pipeline that you have seen before in a more graphical way. But I don't want to do that. I love typing, I love code, I love to check in some code files, and therefore I'm more into automating this stuff in code files, in my YAML files. But you could use the classic editor here if you want. We can also edit the file later on, but yeah, that's up to you if you are more into UI or if you are more into code. It's up to you. The first thing that we have to tell the system is where is the code coming from, and I'm going to select our GitHub project. It happens to be the topmost one. I will select that one. And as you can see, it automatically recognized my existing pipeline. And yeah, looks good. We could edit it here directly, but hey, if we want to edit it, we are going to use Visual Studio Code. So let's go and run this stuff. This will now create the pipeline and run the first version of our pipeline. Let's go here and see what's going to happen. Now, Azure is looking for a nice little software robot, a pipeline agent that is ready to execute our stuff. We didn't create any agent or something. It already picked it up and we got a brand new virtual machine which was created by Microsoft from scratch. It's well documented. You have in the documentation of Azure Pipelines a very detailed definition what software you can require on this stuff. And as you can see, it's running through. It already installed and selected the proper Go version. It's now running the unit tests. I will wait until it has succeeded, hopefully succeeded. Maybe I messed something up, we will see. And in a few seconds, we'll say, I messed something up. Let's see. Let's see. Something was wrong. Let's see what was going on here. What is that? That one is new. I didn't see that when I tried it last time. Let me quickly see here. Go version, everything looks good, and oh my god, the snippets removed the $sign, and so it was looking for a directory called home, and that of course doesn't exist. The $sign at the beginning of the line was removed by my snippet editor. Okay, that's fine. Let's try it again. Again? Oh my god.
Line 30?
Yes, here and line 30. Where? Oh my god. You know what? Let me grab that from my original sample. I'm sorry that the snippets messed up this part of my demo, but I have something here. I will simply go up here and copy everything from the original file. You have seen me creating it step by step, so I think you could follow along, and if everything works out nicely, we now have the $signs. That looks good. So, second try. Publish fix pipeline issues. Good. And push it again. Now, of course, I made this mistake. I planned this mistake. No, I didn't plan for this mistake. But because I checked it in, it should now, in a few seconds, automatically run yes, next pipeline. As you can see, so continuous integration really works. It recognized automatically that I checked in some code in GitHub, and let's see. Currently Azure is again looking for a VM. It found a VM and it starts again. So if I again mess something up, I will show you the ready prepared steps. But yeah, hopefully it will work. Any questions so far while we are waiting for this next step? Yes, question.
Why do you think Azure is using VMs instead of Docker images to...
Oh, I just said VM, whatever it is in the background. You really don't have to care. You can, from the Docker Hub, you get images, Docker images, which exactly match the build machines. Maybe they are using Docker images, whatever they are using you simply don't have to care.
You can use a Docker image instead of Ubuntu 18.04.
The Ubuntu 18.04 was not the VM. It is a code name for a very well-defined build machine by Microsoft. Let me show you what I mean with that. If we go Azure Pipeline agent software, I think with that we should be, yes, here it is. Here you will see a list of all Microsoft provided agents, and if I scroll down, maybe here, Microsoft hosted agents, you will see that they have a bunch of hosted agents, and this is just the name of the hosted agent. And if I go on Ubuntu 18.04 and go for the link, you will see that it gets me to a GitHub page where I can get a detailed list of all the software that is installed on these ready-made containers. And I can even go one level up and go to scripts. And here you see the installers. And if we are, for instance, interested in how Go was configured, we can take a look at the bash script. Everything is open source, and you immediately understand in very great details how these build agents were set up. So Ubuntu 18.04 does not mean a fresh Ubuntu 18.04. It's just the name of the build agent with a very well-defined layout and collection of software. So you can build nearly everything on this stuff. And you can get it for Ubuntu, you can get it for 18, for 16, for Windows, and all this stuff. Please take a look at these links so you can get a lot of detailed information. And these VMs, they are available also as Docker images on the Docker Hub. Whatever Microsoft, the Azure Pipelines use in the background, I really don't care. Maybe they're using Kubernetes, maybe not, I don't care. No, it's not my business. Okay, does this answer your question?
Yeah.
Good. So let's get back here. Ha! Everything is green. Very nice. So if we take a look, yeah, everything is green. Let's take a look how this looks like. As you can see, woohoo, 100% passed. We will see all the tests. We can take a look. Do we really see all the tests? Yes, we see all the tests everything fine. We can also go to code coverage, as you can see it here, and I can scroll down a little bit and click on it, and you will see in green all the lines that are tested, all the other lines that are not tested. So we get this for free. It's just running. It's just a result of the Go test execution, okay? And just to prove the point, I will mess it up, and while the build is running again, we will continue. So if I go here in my math algorithms and for whatever reason I say we expect 42 because it's such a nice number, go and ruin test. Good. And push it. And in a few minutes we will see a failed test where we hopefully see which test broke, and we can take a look at the results. Good. So, if you agree, I would like to continue, and the next step will be building a Docker image, because now we have a web application and we would like to run it in a Docker image. So what I did, I created a Docker file for you. Let's quickly take a look at it. It's really, really simple. As you can see it here, it is based on Alpine. It takes my demo app, as you can see it here, makes it executable, and runs it, and it sets a parameter, command line parameter, that it should run listen on port 80 by default. That is what this Docker image does. Yeah, I just came up with this. I hope that's okay for you. Please imagine your most complicated Docker files that you can imagine. You can run anything here. It's just a Docker file. But this is the demo that I'm going to use. Good. Let's go for it. The next one is this one. This is the next stage. As you can remember, we have multiple stages. The first one was build and test. The second one is now publish Docker image. And we have two steps here. Sorry, two jobs. Again, one job with two steps. Now I got it correctly. So, as you can see, again, I'm using Ubuntu as our build agent. And the first thing that I'm going to do is I'm going to download the artifact. So the build result, which I published as a pipeline artifact with the name executable, I'm now downloading it in my next step. I could use a different VM layout here. I could build it not on Ubuntu, but on a Windows machine. And with these pipeline artifacts, I can copy stuff from one step, from one stage to the other stage. And then I'm going to copy this executable into my sources directory, because I would like to have the executable right beside my Docker file in order to have a Docker context that I can ship to the Docker host in order to build my image. This is what I do here. Okay. Last but not least, we are going to log in on the Docker Hub. You can see it here, and build and publish our Docker image. Now this one is again something that we should mention. As you can see it here, I'm just saying Docker login, no credentials provided here. And that is by design. We are referring here to an externally defined so-called service connection. So what we can do is we can go into our project here and go to project settings. And in project settings, we will see that we have a bunch of service connections. And I created for this demo 2 service connections up front because I didn't want to type in my passwords here on stage. So I typed in my Docker Hub credentials and I typed in my Azure credentials, did the whole multi-factor authentication, provide your fingerprint dance, whatever I had to do. And what I got in the background is I gave Azure Pipelines the permission to access the Docker Hub on my behalf and to access Azure on my behalf. Essentially, they now have a kind of service principal or a refresh token on these systems, and now they can publish on my behalf on Docker Hub, or they can publish on Azure. This is what I did. And inside the pipeline, we are just referring to these service connections by name. Okay? So I can easily check this thing in. Nothing bad will happen because the secret is stored somewhere else. And if I want to get to these secrets, I need to sign into Azure Pipelines. And for that, I have multi-factor authentication, my fingerprint, and so on and so on. And this keeps my service connections safe and secure. Okay, that's the idea here. Last but not least, as you can see it here, Docker build and push. We don't need to write any kind of scripts for that. We just use a ready-made task. We say build and push, give it the name of the repository. I called it r/stropek/demo and give it a bunch of tags. And to make things a little bit more interesting, we are going to use the auto-generated build ID that Azure Pipeline gives us. This is just a number that is incremented whenever we do a build on this build server, that's all. Of course, you can build a more complicated build number on your own with some kind of templating and so on, but I didn't think that this would provide anything additional information to this talk, so I kept it simple. Just a build ID. Good. Good. The next one is already publishing to Azure, and I learned I will not use the snippets, but I will copy my working code just to make sure that no $signs are removed. Good. That's exactly the same code that I created with snippets. Okay, so please bear with me. Let's save it. Let's go here. Let's take the Azure pipeline and say add Docker build. Go for it and publish it. Good. Oh my God, this will break because I still have the mistake in my unit test, right? While this is pushing, we can take a look at the results. Good. Hopefully we have a broken build. Yes, we have a broken build. That's exactly what I wanted to show. Let's go into the jobs. Yes, our unit test broke. So let's explore which test broke. And as you can see it here, 50% broke. And as you can see, test next. This is the test that I messed up. Let's go back and let's check it. Yes, it's the test next. And we have to fix this one. And now it's fine. So let's get this in order. Take this one, fix test, and push. This will trigger another build. Maybe you have seen, if you watched very closely, that we now got a new item here, because now we have multiple stages. The first stage is building and testing. The second stage was publishing the Docker image to the Docker Hub. And we will get a third stage in just 2 or 3 minutes when we publish everything into the Azure cloud. Okay? So these are the different stages. And of course, between the stages, we can, for instance, add some manual steps where we need approval from some kind of quality assurance stuff for managers or whatever. So we can have breaks, if you want to put it like that, so-called guards, or different names for that, where we can say, hey, stop here, we need to do something. Okay, we need to manually take a step, or we execute some additional tests, and only after testing we can allow the system to continue. Okay, first one broke. Yes, I know, I did that. So, did I already check it in? Yes, I already checked it in. Let's take a look. Yes, one is running. That is good. And this one should now succeed. As you can see, this is the user interface of the multi-stage build. We will see stage by stage what's going on. And inside the stages, we see the different jobs that run on different build machines. And in our case, we just have one. We just have the Ubuntu one. I think you get the idea. Looks good. It already published some artifacts and 100% test passed. So let's wait just a few more seconds. Yes, it's green. So now the publishing of the Docker file will do. And I already did it up front. So we already have it in Docker, but it should really work. In a bunch of seconds, we should see it. Let's give it a try just to prove the point. It's now downloading the pipeline artifacts. This is the executable that I published it. It copies it. It then logs into the Docker Hub, and now the building and publishing of the Docker image runs. And please keep in mind, I created everything from scratch. I didn't invest a single second in setting up these build agents that with this whole UI, I didn't set anything up, and I get all this for free if I work on open source projects. I think this is really a great offering. So yeah, it's running, looks good, looks good. It will take a bunch of seconds more, but that's fine. Let's continue with our Azure pipelines. I think you got the point. Hopefully I can prove to you that it really works. It works, you can trust me. Last but not least, I would like to publish everything on Azure. And how do we publish on Azure? I didn't create anything on Azure. We have no VM, no AKS cluster, nothing like that. We would like to use a platform as a service or serverless offering, which is called Azure Web Apps, which is perfect for just running a web API, a website, or a WebSocket-enabled web application in the cloud. It's an abstraction on top of maybe Kubernetes, maybe not. Again, I don't care. I just provide a Docker container registry, I provide a repository name, and I tell the system, run it. How? I don't care. Just run it. Give me a reverse proxy with some firewall stuff and all this stuff, and just optimize it for web. This is what I'm going to do. And to do that, we again describe the whole system in a configuration file. And in Azure, one possibility beside Bash scripts and PowerShell is so-called ARM templates, Azure Resource Manager templates. And they look like that. At first, we define some input parameters. Yeah? Infrastructure is code. Infrastructure is JSON in this way. And it starts with parameters. The parameters can be provided from outside. I can make my ARM template flexible. Do I want to deploy to West Europe or North US? Or do I want to have a big cluster machine or a small one? Do I have to 1 or 5? This is the kind of parameters that we can provide here. Next, we have to provide some variables, very simple, very similar to what we have seen before. Variables, oops, here it is. I can make some image names variable. I have some string operations where I can build some things. I have a very powerful expression language. I cannot go into the details because this is not an ARM template training, but I think you get the idea what these variables are all about. And last but not least, I'm going to create a server farm. The server farm, as you can see it here, consists of a number of machines. In my case, I'm using free tier, so hosting this application is also completely free, not just for 30 days. And here I could, for instance, say how many web applications I would like to have. They are hidden behind a reverse proxy, load balancer, and all this stuff. I don't have to care for the details, they do it for me. Last but not least, I tell it that this is a Linux machine. The server farm now can host multiple web apps. Each web app will become a collection of Docker containers. It's similar to a pod if you want, okay? You can run multiple containers inside a web app, and now we will tell the system that we would like to have a web app. This is the website. The website now runs on the server farm, and here I have to tell the system that it should get the image from the Docker Hub, and I will specify the name, our Stropek/demo, and I will specify here the version that I would like to run. And guess what? The version, demo app image version, up here is a parameter. Whoops. Come on. Now I got it. Here. It is a parameter, and where does it come from? From the build. Because when the build now publishes everything to Azure, it will tell the system, hey, I just built the build ID 752. Please take the Docker image version 752 and deploy it. And the nice thing with ARM templates is, if I don't have anything in Azure, it will spin everything up from scratch. I don't have to do anything manually. And if I run it a second time, it will do a diff, similar to, I think, what Terraform does. So it does a diff. What changed? Oh, Rainer only changed the label of the Docker image. I don't tear everything down and create everything from scratch. All I need to do is I need to update the image. Get the idea? I could also change the number of machines from 1 to 2, deploy everything again, and it will recognize, oh, Rainer only changed the number of workers. So I will just take another web server, put it there, reconfigure the load balancer, and I'm done. That's the idea. It's idempotent. You can deploy this stuff idempotent. Good. Nice. I learned something. Don't trust the snippets. So I will copy the code again from my ready-made sample. Good. Last but not least, we need to put this deployment to Azure into our pipeline. Let's do that. WAML. Oops. WAML. Here it is. Only 2 steps more and then we are done. Publish to Azure. Again, it's a new stage. It's a new job. It runs, in my case, on Ubuntu. And this step looks a little bit complicated, but it's really simple. It just says deploy something to Azure. I give it a name, resource group name Gophers meetup Linz. I give it a data center location, West Europe, and I will tell some parameters which will drive my Azure publishing. Deployment mode incremental means exactly what I told you, idempotency, only update the things that are new. Don't tear everything down and build everything from scratch. Last but not least, to make our application really nice, we will do a warm-up. Warm-up means that I'm running a simple curl against my web application and check whether curl responds with an error. Because if it doesn't reach the thing that we just deployed to Azure, we are going to fail because we want to have continuous delivery, and I'm going to create a very trivial, let's say, smoke test whether the deployment really worked. Get the idea? Of course, in real life, you would do much more interesting tests here to check whether the deployment really worked, but I think you get the idea, right? Okay? Good. Just to make sure, you know the drill. Let's copy the last ones out here to be sure that I didn't screw up with the dollar signs again. Good. Same code. Now we will publish both changes, Azure deployment and push it. Let's check whether the build starts. It should start in a second. And here it is. It's running now. We have 3 stages. Let's keep it running. Here in Azure, let me quickly show you that I'm not cheating. You see, if I look for Goph, there is no resource group, nothing. It's empty. I don't have any AKS cluster, no VMs, nothing. I really do everything from scratch here. So let's check whether it works. Let's take a look. Okay, it's currently building and testing, and we'll see publishing and publish the app. For the sake of time, if I messed up something and we don't see green checks here, I'm going to show you the ready-made example that I already deployed just to make sure. So please don't be angry with me. I only have 45 minutes and sometimes I simply mess some demos up. Hopefully we will see green checks. But now we have approximately, I would say, 2-3 minutes where you can maybe ask some questions while we are waiting here for the build to continue. Any questions from your side? No questions. That means either I bored you to death or everything was clear. For me, let me describe a little bit why I'm so fascinated from this technology. I'm really a passionate software developer. I love writing code. I love writing code in Go, in .NET Core, in TypeScript and so on. I don't like maintaining servers. I hate that. Therefore, platform as a service and serverless is really, really important for me because with that, I don't have to care about the infrastructure. I love Docker, but I don't like Kubernetes because it's way too much ops in the DevOps world. And therefore, I like infrastructure. I like platform as a service and serverless. And this is what my talk was today all about. Using ready-made components in the cloud to reduce the ops work as much as possible and to increase my developer productivity as much as possible. So building was successful. Now it's publishing the Docker image. Let's see whether this works. I think we haven't seen that one. So login was successful. I can go here. Yes, it's currently building. It hopefully will be done in a second. While this is running, I can describe another thing. If you say, oh, I can't do that because I don't have all my artifacts in the cloud. What you can do is you can run those build agents based on the Docker images from the Docker Hub in your own data center on-premise. Well, looks good. You can run it on-premise, and if you run it on-premise, you can still use this nice UI because the build agents which run on-premise and which can access your local resources, they will be orchestrated by Azure Pipelines in the cloud. So they contact it and they will be driven by the cloud. And therefore, everything I show you here can be done on-premise too, without having to lose all this stuff. But still, you have then to care for the servers on-premise and things like that. But this is definitely possible. And for some companies or some scenarios where I definitely don't want to give the software to Microsoft, for instance, this is an important aspect. So as you can see it here, it's currently publishing. And if we take a look here, I'm nearly done, I promise. So, do we already see the Gophers? Not yet. Let's refresh. We could also wait a few seconds, but time is running. Here, Gophers meetup Linz. Okay, and you see here, deployments. If I click here, we can take a look. Yes, deployment is currently running, and it's now, oh, it already created server farm, and it created the sites. It looks really nice. Maybe we really see it working. As you can see, the app service plan is already here. The website should appear in a second if we take a look here. It already deployed it, but trying it failed. That can be a timeout. Maybe it was a timeout. Let's see. Let's see. Go here and say fib. Yes, it only was a timeout. I'm sorry, I created a timeout of 15 seconds, and the free version of the web app is sometimes, when setting it up from scratch, a little bit slow because it's free and it's a very small machine. But you see, now I could show you exactly what I wanted to show you. I could show you that we have a pipeline. Please ignore the last one, it really worked, you saw it. A pipeline created from scratch, building the Go app, testing the Go app, doing some code coverage, putting it on the Docker Hub, and then driving some cloud resources and pushing it into Azure using the ARM template. This is what I wanted to show you. I'm very glad that it worked at the end. So, thank you. I hope it was an interesting 3/4 of an hour. I recorded the whole session. Hopefully it will work. I will put it on YouTube on my YouTube channel. So if you want to keep in touch, then the easiest way to do that is to visit my digital business card if you want, rainerstropek.me. And here on the right lower corner, you will see a bunch of links, including LinkedIn and Facebook and whatever, Twitter and YouTube. And yeah, use one of these links. Let's connect and let's keep in touch. Thank you very much. If you have any questions, I'm more than happy to answer them. Thank you.